Hi, this is Mrs. Boykin with another Algebra 2 educational video. We're talking today about solving quadratics by using the quadratic formula. First of all, I need to point out to you that whenever we use this formula, we need to make sure that our equation is put in standard form. Standard form being that the exponent of the highest degree is first, followed by your x term, and last your numbers, your constants, your integers, and they're set equal to 0. They must be set equal to 0 before you can apply the formula. So this is the formula that we're going to use, and there's a quadratic formula song, but you're not going to catch me singing it on the tape, so we'll have to save that for class. Here's a special note, though, as I said, that all equations must be written in standard form and must equal 0 before using the quadratic formula. And some things that I've seen in the past from students is nowhere do we use the variables when using the quadratic formula. I'll see students put in the x's or x squareds. We don't use the variables. We only use the numerical values of a, b, and c. And this is what I mean by a, b, and c, the numbers located in those positions. So why don't we get started with our first problem. I tried to get some problems that had a variety, and they have a variety of solutions and different little things that might pop up here and there when we're working them. So as you can see, our equation is not set equal to 0, so that's where we need to begin. And we're going to move this negative 6 and the positive 8x over to the other side, so we need to add 6 and subtract 8x from both sides. So if you kind of envision this being split, of course they cancel out, they're going to equal 0, but now we need to rearrange these in order from highest degree to lowest to constant. So it's going to be a positive 6x squared, the negative 8x comes next, and the positive 6 comes last, and we're setting it equal to 0. Now one of the things that I like to do is to go ahead and identify what the a, b, and c equals. So let's do that. A equals 6, B equals a negative 8, and C equals a positive 6. And it's important that you pay attention to your signs. So let's take a look at that formula. X equals a negative b plus or minus square root b squared minus 4ac, 4 times a times c, and the whole thing, not just the radical, the whole thing is all over 2a. So let's go ahead and substitute in. Now keep in mind that we're substituting in place of b. The negative must be applied, and we're going to place b in both locations. So let's go back. We have x therefore equals a negative b. Now b is a negative 8. Make sure you include that negative. Plus or minus square root b squared. Now b is a negative 8. It must be in parentheses when you're calculating this portion, otherwise you're going to get an incorrect sign. 4 times my a value of 6 and my c value of 6. So your first step should always be plugging in the numbers. Don't try to do anything fancy or any calculations. They're all divided by 2a, which is 6. Okay. From this point here, we can start simplifying and cleaning things up. So we're going to have x equals a negative times a negative 8 is a positive 8, plus or minus square root, and underneath, let me put this in red, negative 8 squared is a positive 64, minus 4 times 6 times 6 is a negative 144. All divided by 12. Alright, now again we're going to focus on consolidating what's underneath the radical. I'm going to erase this information here just to give me a little bit more room for calculating. Okay, so if we're calculating 64 minus 144, let's put that up there. X equals 8 plus or minus, and that would be negative 80 all over 12. So now we need to simplify the negative 80. Well, we know that having a negative sign underneath the radical is not where it needs to stay because the square root of a negative 1 equals I. So we need to pull out an I. Square root of 80, let's take care of that using our graphing calculator. Okay, so here we are in our graphing application, and we're going to simplify the square root of positive 80. We already took the negative out. So if you remember correctly from simplifying radicals, we're going to do 80 divided by x squared, because x squared is the opposite of the square root. Hit enter, Control T to get to my table of values, and we're going to scroll down. We're going to look for the decimal beginning with 0, and there it is. Now we're going to scroll backwards to find the first set of whole numbers, and here it is, 4 square root of 5. So let's go ahead and write that in. So 4 goes on the outside, square root of 5. Why do we have the I there? Again, because square root of a negative 1 equals I. So a negative 1 times a positive 80. All over 12. Our last step, and if you'll allow me to clean up some more on my board over here. Our last step is to do any last simplifying there might need to be. What I'm talking about is any of the numbers outside the radical, the 8, the 4, and the 12. We need to ask ourselves, is there a number that all 3 can be divided by? And it must be all 3. And we can divide each of those by 4. So the 8's going to get divided by 4, the 4 will get divided by 4, and this 12 will get divided by 4. So let's go ahead and write our final answer. X equals 8 divided by 4 is 2. 4 divided by 4 is 1, or 1i, or just I, square root of 5, and 12 divided by 4 is 3. So we actually have 2 solutions. This represents 2 plus I square root of 5 all over 3, and also 2 minus I square root of 5 all over 3. And those would be our 2 solutions to this first problem. Sorry about the sloppiness. I'll try to write a little smaller on the next slide. Alright, let's take a look at that one. Okay, again, we need to get our terms over to the left-hand side. So let's go ahead and start. We're going to basically subtract 14, and we're going to add 9x. So I'm going to write it up here. 5x squared plus 9x minus 14 equals 0. I subtracted from one side, or I took away from one side to bring over to the other. So this will be our equation. Again, we're going to identify a equals 5, b equals 9, and c equals a negative 14. Okay? So let's do our formula. X equals a negative b. So negative 9 plus or minus square root b squared minus 4 times a of 5 and c of a negative 14 all over 2a. Okay, so now that we've plugged everything in, we're going to go ahead and start simplifying and see what we end up with. Alright, so x equals negative 9 plus or minus square root. 9 squared is 81. Multiplying a negative 4 times 5 times the negative 14 is a positive 280. And 2 times 5 is 10. Alright, so 81 plus 280, negative 9 plus or minus square root of 361, is what it would add up to be, all over 10. this is where we're going to come over here. We're going to simplify the square root. So going to my graphing application, and I'm going to type 361 divided by x squared, Control T, and I'm going to scan for my 0, and there's my 0. Working backwards, I see this is 9 square root of 1. 19 square root of 1, sorry about that. 19 square root of 1. Well, the square root of 1 is 1. So it's actually a full 19 that's coming out. So x equals negative 9 plus or minus 19, because the square root of 361 is a perfect square, it's 19, all over 10. Now for this scenario here, we cannot add and subtract simultaneously, so we need to break this down into two parts. So this actually represents x equals a negative 9 plus 19 all over 10. Negative 9 and 19 make 10 over 10, which equals 1. My second problem is the negative 9, this time minus 19, all over 10. And a negative 9 minus 19 is a negative 28, all over 10. And we can simplify that fraction to a negative 14 fifths. So again, we have two solutions, positive 1 and a negative 14 fifths. A little bit different. Here's my third example. Again, we need to get the right-hand side equal to 0, so we're going to add 4x to both sides. So this is a negative 6x squared plus 9x minus 5 equals 0. Now, hopefully you notice that this is the first time we've had a negative to start out our quadratic, and you know how I feel about anything starting out with a negative. It's got to go. So we're just going to multiply both sides by a negative 1, and then we get positive 6x squared minus 9x, because we're multiplying by a negative 1. And a negative 1 times the negative 5 is a positive 5 equals, and a negative 1 times 0 is still 0. Alright, so now we're going to identify our A equals 6, our B equals a negative 9, and my C is a positive 5. So let's plug it into the formula. X equals a negative B, which is negative 9, plus or minus square root B squared. B is my negative 9 squared minus 4 times the A value of 6 and the C value of 5. All divided, the whole thing, by 2A. So 2 times the 6. Now I'm getting fancy with my colors. Okay, so let's go ahead and simplify. X equals negative times the negative 9 is a positive 9, plus or minus square root 9, negative 9 times the negative 9 is a positive 81, minus negative 4 times 6 times 5 is a negative 120. All over 12. Notice how I'm just simplifying chunks, okay? If you want to put this whole thing, negative 9, parentheses 2, minus 4, parentheses 6, parentheses 5, all in at once into the calculator, that's totally fine. So we end up with 9 plus or minus square root of 81 minus 120 is a negative 39, all over 12. All right. So let's go ahead and take a look at this. Now, what can we simplify? Well, first thing that I'm looking at here is I don't like the negative being in my radical, so we're going to pull that out. X equals 9 plus or minus I square root of 39, positive 39, all over 12. All right, So now we have to take a look. Square root of 39, that cannot be simplified. After that, we need to see, can this be simplified by taking a look at 9? This is basically a positive 1 and a positive 12. Well, I know 9 and 12 can be divided by 3, but 1 can't. So we're going to leave it. So my two answers are x equals 9 minus I square root of 39 all over 12, and 9 plus I square root of 39 all over 12. My two solutions. And there we have it. This is my last and final problem. I think that 4 examples should be sufficient. So again, we got lots to move this time. We're going to be subtracting the 8m squared, we're going to be subtracting the 2 and subtracting 6m from both sides. To save the writing, I'm just going to go ahead and combine. So the 14m squared and a negative 8m leaves me with 6m squared. I have a negative 6m that I'm moving over here. And then I have this negative 7 and a negative 2 make a negative 9 equals 0. Now, if you would like to show this over here, and go ahead and combine like terms, you'll end up with this. I was just running a little tight on space. So let's identify what our A, B, and C are. A equals 6, B equals a negative 6, and C equals a negative 9. Don't forget the negative signs. Okay, let's do our formula. X equals a negative B, negative times a negative 6, plus or minus square root the negative 6 squared minus 4 times A times C all over 2 times A. Alright, so I'm going to flip over to the calculator. I'm going to show you what I'm talking about when I say calculate what's underneath your radical. We don't want to use the radical, we just want to calculate what's underneath the radical. So we need to use a parentheses, negative 6 squared minus 4. Our A value was 6, and our C value was a negative 9. Close it, and that's 252. So that's everything underneath our radical. So x equals negative times a negative 6 is a positive 6, plus or minus square root, and we calculate that to positive 252 all over 12. All right, so let's go ahead and simplify the square root of 252. Going to my graphing app, we have 252 divided by x squared, and Control T, scanning that table down to look for the 0 when we simplify a radical. Oh, there's a 0. Let's work our way backwards to find the first pair of whole numbers. 6 square root of 7. 6 square root of 7. So we have x equals 6 plus or minus, that was 6 square root of 7. There's no I because 252 is positive, all over 12. And we're almost done. Let's take a look at the numbers on the outside. We have a 6 and a 6 and a 12. I think all of those can be divided by 6. So we're going to divide each by 6. And we end up with our answer. X equals 6 divided by 6 is 1, plus or minus 6 divided by 6 is 1. We don't need to write the 1. 1 times a radical 7 is still just a radical 7. It's not wrong, but it's just not necessary. And 12 divided by 6 is 2. So again, remember we have to split these apart. Two solutions, 1 plus or minus square root of 7. Oh, I didn't mean to say plus or minus. It's late. Okay. All over 2. And my second one is 1 minus square root of 7. all over 2. My 2 solutions to my quadratic. And so that is the lesson for today. I do have an extra page for you. If you would like to see a written explanation of using the quadratic formula, I've got a website below. Embedded in this website is a video of another teacher explaining how to use the quadratic formula. If you think you need to watch that, you're more than welcome to. But this is Miss Boykin signing off for tonight. If you need extra help, come to CAD Morning. Otherwise, I'll see you in class. The problems that I assigned for homework were not the quadratic formula, but it was not quadratic equations, I should say, but it was the parts of the quadratic formula put into place. All I'm asking for you is to calculate what's under the radical and simplify, just like I did on the video. So part of the work was already done for you for this homework assignment. Next time, you'll get the full deal. See you tomorrow. Bye, guys.